Hey guys, in this video we are going to talk about how to plot a vertex form and how to plot it in a quick fashion as well. And we will summarize all the features of the parabola after that. Before we do that, let's get into plotting the base graph. The base graph, we know is y equals x squared. We have 0, 0, 1, 1, 2, 4, and 3, 9, 5, 6, 7, 8, 9. Okay, let me count that to make sure it's right. 4, 5, 6, 7, 8, 9. Okay, and then reflecting it on the other side, we get the full base graph like this. All right, so what do we know from this base graph? We know that the 0, 0 is the vertex, and this coordinate is 1, 1. So when you go right 1 unit on the x-axis, you have to go 1 unit up. Then if you go right 2 units on the x-axis, you go 4 units up. And then when you go 3 units on the x-axis, you go 9 up. So these numbers you should know at the back of your hand, like the back of your hand. And when you know these, you can plot any given quadratic and vertex form very, very quickly. So here's an example for you. So we have this negative 0.5, that is your y stretch factor, and then you have the 4 and the 3, from which we know that the vertex of the parabola is negative 4 and 3. In earlier classes and videos, we talked about we have to switch this number 4. If it is positive, we switch to a negative. If it's negative, we switch to a positive. But we write the 3 as it is. So the first thing you do is plot that vertex on the graph. So negative 4, 1, 2, 3, 4, 1, 2, 3. That is the vertex. The vertex is negative 4, comma 3. So the negative in the equation here, in front of the negative 0.5, tells you that the graph opens up. And the 0.5 tells you that these are the normal steps, 1, 1, 2, 4, 3, 9. The 0.5 tells you that the y values, they are going to be stretched by a factor of half. So instead of going to 1, 1, it'll go 1, 0.5, 2, 2, half of 4, 3, 4.5, half of 9. But the direction in which it's going to go is down because it is a reflection. It is the A value is negative. So the way it's going to go is 1 to the right, and instead of going 1, it'll go 0.5. You have to go down because of the reflection. And then 2, instead of going to the 4, we go half as much, that much. And then we go 3, instead of going 9, we'll go 4.5. So this is 2 already. 3, 4, 4.5. Okay, now there's more room for plotting extra points. So normally it'll be 4, 16. Instead it'll be 4, 8. So if we go 4 to the right, 1, 2, 3, 4, 4 to the right, you'll have to go to 8, 8 down. So we go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have one branch of the parabola, and at this point we can draw a axis of symmetry that goes right through. Okay, and once we have the axis of symmetry, all we do is reflect the points on the other side. And we have the parabola. And as you can see, I took very little time to graph this. Okay, so what other further information that we can get from here? So we know that as the first information, the vertex is 4, 3. The second piece of information is the axis of symmetry, that is x equals negative 4. And the third information here is the maximum or minimum value, also called the optimum value. So we have a y max value, max, and that is equal to 3. And we know that the parabola opens down. Parabola opens down, and using the information that we learned from the previous video, we know that we can talk about the domain and range. Domain, we know that for parabolas, the domain x belongs to real numbers, and the range, we know that the maximum value, the max value here is 3, the y max, which means every other value on this parabola is going to be less than or equal to that. So you write y is less than or equal to 3, but you also have to say what kind of numbers that y will take. I'm sorry, I said x. What kind of numbers y will take? Y will take all real numbers just like x. Okay? And finally, there's another piece of information that we can get, and that is about the y-intercept. It so happened that when I plotted this graph, the y-intercepts happens to be 1, 2, 3, 4, 5, 0, comma, -5, but it's a lot easier to get this from the equation itself. Consider this equation, y equals -0.5 x x plus 4 squared plus 3 right there. So this is what happens. On the y-axis, notice here, on the y-axis, the x value is 0. Okay, this is true at all times. On the y-axis, x value is 0. So if I like the y value, all I need to do is, this is the rule that you always follow, to get y-intercept, we always set the x value to 0 in the equation. So set x equal to 0, -0.5, 0 plus 4 squared plus 3, that is -0.5. This is 0 plus 4 is 4. 4 to the power of 2 is 16 plus 3, and then that is -8 plus 3, -8 plus 3, and that is equal to -5, which is what you see in the graph. So the y-intercept point would be 0, -5. Remember, not always the graph will directly give you the y-intercept. You may have to use this equation and substitute the 0 into the equation and calculate the y value to get the y-intercept. See you in the next video.